Before I start this section, I'll start with a small disclaimer. This section was developed after the application was almost finished, and so the code you see attached to it includes many additional features that, if you will look through, aren't covered in previous modules. However, it does fit in this location, so I took the liberty of sticking it in. I mentioned before, push is fragile and can be blocked by the user. In order for the app to work properly, we need to properly handle the situation where push isn't available, and we can do that with a fallback implementation. I already demonstrated the HTTP polling implementation. Now I'd like to move to the better solution, which is WebSockets. But first, if it's a better solution, why didn't I start with that? WebSockets are newer, and some server developers might not be as comfortable with them. They are worth your time and effort though, as they make event-based communication trivial and efficient. HTTP is a relatively expensive protocol. Besides the cost of opening a socket, we also have the cost of the headers. This gets really bad when you go back and forth from client to server for many small requests. HTTP works great when you return large files which effectively mask the overhead of the protocol. Sockets are too low level for the web environment. They don't work nicely with most application servers, and it's really difficult to punch through corporate firewalls. Sockets are also very fragile, and it's really hard to deal effectively with failure when working with them. WebSockets were devised as a middle-of-the-road solution. They start as an HTTP or HTTPS connection, but instead of closing the connection, the server keeps the socket open, and now the client and server can communicate freely back and forth. This has several advantages. You can go through corporate firewalls who are mostly oblivious to WebSockets as they seem like a regular web traffic, which they are. A lot of application servers have standardized support for WebSockets since they are a W3C standard. You can easily work with your favorite server. Coding is as efficient as regular sockets once you paid the connection overhead cost. And finally, you can use WebSockets from Codename 1 as well as JavaScript and pretty much everywhere else on the client. WebSockets aren't as flexible as regular sockets since the API is a bit simplified. You can send and receive messages either as bytes or as strings. That's very convenient. One of the harder problems with WebSockets is actually in the server. A lot of server APIs are very synchronous by nature, and it's sometimes hard to bind an event from the server to a socket event. In fact, that's the biggest difficulty I had when working with WebSockets, doing the right thing in Spring Boot. Spring Boot has an optional standardized protocol on top of WebSockets, which I didn't use as I wanted something very low level and that seemed redundant. This is the one problem with WebSockets. They are relatively new and a lot of the best practices haven't caught up yet. WebSocket support in Codename 1 is implemented as a CN1 lib, which you can install by launching the Codename One Settings app and going to the Extensions section. When you press the download button, the library will be installed. Just use Refresh Libs in the right-click menu, and you can proceed to use the WebSocket library. In the code, you might recall the build app method that builds the actual app. We now open a connection to the server with the WebSocket class. The WebSocket class includes callbacks representing the various states of the WebSocket. The first callback is an onOpen. You will notice I'm sending the secret to the server so we can bind to the right restaurant. Initially, I didn't pay attention to it and just called the send method directly after creating the socket object. This didn't work, but I didn't get any error either. Since the socket works asynchronously, it wasn't open and my call was failing. This method is crucial for the initial handshake code. You'll notice we have two onMessage methods. As the WebSocket API, one accepts string and the other a byte array. This maps to the way WebSocket API works, where a special case is made for both of these types. We only pass strings here, which map directly to the messages we would have gotten from the push notification API. Scrolling a bit downwards, we can now see the onError callback. It's important to override that to handle errors. We can then see the sock.connect method, which initializes the connection. For this specific trivial usage of WebSockets, this is literally the entire client side, but even more elaborate usage isn't much more complicated than that. WebSockets are just messages we send and receive, and the client side is remarkably simple. On the server side, we need to first create a configuration class to handle WebSockets. I define the standard 8 kilobyte buffer size and add a handler for the specific WebSocket URL. Scrolling further down, we can see the handler instance that's created when a handler is needed. The handler class will handle a WebSocket request. The handler class implements a text-based WebSocket, which means it works with text objects for the WebSocket. As you recall, WebSockets work with either binary data or text, and in this case we only work with strings. This is a bit of a hack. I probably could have found a better way to implement it if I had more time, but as I mentioned before, WebSockets are new and some of the older APIs just don't fit very well into the paradigm. I want the asynchronous build process to send a WebSocket message, but there is no way to do that without somehow passing the WebSocket reference to the build. Unfortunately, the build is started via a web service. A long-term solution might be to use only WebSockets for everything, but for now I kept a static instance. This is bad practice as it won't allow the app to scale, but I can live with this at this point. I remove the session entries as a connection is closed, so we don't have a memory leak. The rest of the code in this class is pretty simple, but let's go over it block by block. Since WebSockets are very low level, we can potentially stream data as we work. This isn't as easy to handle, but might be more efficient in some cases. We don't need that. The push method allows us to send a push message to the restaurant with the given secret. This is just a lookup within the session static object and sending the message if we have a session. This effectively works exactly like push. We only send one message to the server, and that's the client secret. We rely on that here as we cache the session on the server on the secret value. This effectively is the server. The build process calls push in all of the places it sends a push notification. This is pretty trivial, so I won't go into that. Thanks for watching. I hope you found this informative.